Hi everyone. Today in this video I am going to solve how to find the particular integral when right hand side is e raised to ax. So let's get started. Hi everyone. Today in this video we are going to find the particular integral when the right hand side is exponential function, that is e raised to ax. So far we have studied the complete solution when right hand side is 0. If the right hand side is 0, then the particular integral is absent. But in this case we have to find the particular integral when right hand side is e raised to ax, that is particular integral particular integral when right hand side RHS is e raised to ax, that is theorem. Prove that 1 divided by f of d of e raised to ax is equal to 1 divided by f of a into e raised to ax, provided f of a not equal to 0. So first we know that to prove this I will write we know that. What is differentiation of e raised to ax? D of e raised to ax means differentiation of e raised to ax is e raised to ax and differentiation of ax is equal to a. So differentiation of e raised to ax is equal to a into e raised to ax. What is second differentiation of e raised to ax? Second differentiation of e raised to ax is equal to a square into e raised to ax. Similarly, what is third differentiation of e raised to ax? Third differentiation of e raised to ax is equal to a cube e raised to ax. Continue in the same way. What is nth differentiation of e raised to ax? Nth differentiation of e raised to ax is equal to a raised to n into e raised to ax. Now if you see here, in this case the left hand side term, this is d square, d cube, so on up to d raised to n is a function of d. So we can write it as f of d is a function of d, that is f of d. Remaining term is e raised to ax is equal to, right hand side if you see you will get a square, a cube and a raised to n, which is a function of a. So we can write it as f of a into e raised to ax, and if you operate 1 divided by f of d on both the sides and then 1 divided by f of a on both the sides. So first I will write operating 1 divided by f of d on both sides. We get what we get here, that is operating 1 divided by f of d means this is 1 divided by f of d, and then the remaining term is f of d into e raised to x, means multiplying with 1 divided by f of d to the previous equation, and that is equal to 1 divided by f of d into f of a into e raised to ax. where this f of d and f of d get cancels, means you will get e raised to ax is equal to 1 divided by f of d into f of a into e raised to ax, and then divide both the sides by 1 by f of, divide both the sides by f of a, divide both sides by f of a. What you will get? 1 divided by f of a into e raised to ax is equal to, right hand side f of a and f of a get cancels, you will get 1 divided by f of d e raised to ax. So please remember, this implies 1 divided by f of d e raised to ax is equal to 1 divided by f of a into e raised to ax, where the denominator f of a is not equal to 0. So to find the particular integral when right hand side is e raised to ax, just we can replacing d by a. We have to put the value for d is equal to a, and a value is we can obtain from the power of exponential. Okay, here you will come to know if you solve the examples. Before that I will write remember. So first you can write remember. One divided by f of d of e raised to ax is equal to x divided by 1 factorial e raised to ax divided by f dash of a, where f of a is equal to 0 and f dash of a not equal to 0. Similarly, 1 divided by f of d e raised to ax is equal to x square divided by 2 factorial e raised to ax divided by f double dash of a, where f dash of a is equal to 0 and f double dash of a is not equal to 0. Continue in the same way. So this note we can use in the examples. Here, to find the particular integral of right hand side e raised to ax, just we have to put the value of d is equal to a in denominator. After substituting the value for d is equal to a, if you get f of a is not equal to 0, then itself is the required solution. But after substituting, if you get the denominator is equal to 0, then you can differentiate the denominator and you can write it as x divided by 1 factorial e raised to ax divided by f dash of a, means you have to differentiate, and after differentiating again put the value of d is equal to a. If you get a constant value, which will be the required solution, and after substituting again if you get 0, then again you have to differentiate second time and then put d is equal to a. Examples: solve d square y by dx square, d square y divided by dx square minus 5 into dy divided by dx plus 6y is equal to e raised to 4x. So far we have solved examples where right hand side is 0, but here right hand side is e raised to 4x, and if right hand side is e raised to 4x means we can find the particular integral. To find the particular integral, first write down auxiliary equation, or the above equation can be written as d square minus 5d plus 6 bracket complete y is equal to e raised to 4x. Now auxiliary equation is, I will write AE. Auxiliary equation is, that is m square minus 5m plus 6 is equal to 0. So this is a quadratic equation. If we simplify this quadratic equation, you will get two values for m. Find the two factors for 6. You will get minus 3 into minus 2, that is plus 6, and minus 3 minus 2 is equal to minus 5. So we can write it as m square minus 3m minus 2m plus 6 is equal to 0. From first two terms you can take m common. We are left with m minus 3. And from last two terms you can take minus 2 common. Again we are left with m minus 3 is equal to 0. So here this m minus 3 and m minus 3 is common, and that is m minus 3 if we take common, then we are left with m minus 2. M minus 2 is equal to 0. That implies m has two values. M is equal to 3 and one more value is equal to plus 2. Therefore, complementary function CF is equal to, both the roots are different, so complementary function can be written as C1 e raised to 3x plus C2 e raised to 2x. So this is complementary function. Only left hand side we have solved. But what about this right hand side? Here right hand side is not 0. Here right hand side is exponential function. And when right hand side is exponential function, we have to find the particular integral. So particular integral, we will denote it by pi. And what is formula for pi? That is 1 divided by f of d. 1 divided by f of d into e raised to ax. This is particular integral formula. So here I will write 1 divided by f of d into e raised to 4x. Exponential is e raised to 4x. But what is f of d? This is nothing but f of d. This d square minus 5d plus 6 is equal to, this is f of d here. F of d is an equation which is in terms of d. So that is 1 divided by d square minus 5d and plus 6 into e raised to 4x. Now here, to find particular integral, we have to put d is replaced by a. Put d is equal to a value. And what is a value? This is the value for a. A is equal to 4. This is a value. A value is equal to 4. And if you put d is equal to 4, you will get 1 divided by d square. D square is nothing but 4 square, that is 16, minus 5 into 4, that is 20, plus 6. And on simplifying, you will get 2. That is, right here I will write e raised to 4x as it is, and on simplifying you will get e raised to 4x divided by 2. So this is particular integral. Now complete solution CS is equal to CF plus PI. The given equation, which is in terms of y, means this is y is equal to complementary function value is C1 e raised to 3x plus C2 e raised to 2x plus particular integral value is e raised to 4x divided by 2. This is the required solution. Next example, solve d square y by dx square minus 3 into dy by dx plus 2y is equal to e raised to 3x. So in this case also, first I will write the given equation can also be written as d square minus 3d plus 2 bracket complete y is equal to e raised to 3x. Here right hand side is e raised to 3x, means we have to find the particular integral. So first we have to find auxiliary equation, and auxiliary equation is given by m square minus 3m plus 2 is equal to 0. So this is a quadratic equation. If we simplify this quadratic equation, you will get two roots. I'll write the value for m directly, 1 and 2. You will get m is equal to 1 and 2. Therefore CF is equal to, what is complementary function? Both the roots are different, means C1 e raised to x plus C2 e raised to 2x. This is complementary function. Now we have to find particular integral of e raised to 3x, right hand side term. So how to find the particular integral? 1 divided by f of d. F of d is nothing but d square minus 3d plus 2 into e raised to 3x. We have to compare this e raised to 3x with e raised to ax. Then what is the value for a? A is equal to 3. So put a is equal to, means d is equal to a. Put d is equal to a, and what is a value? A value is equal to 3. So this is equal to 1 divided by, what is the value for this d square? D square is nothing but 3 square, and 3 square is 9, minus d value is equal to 3. 3 into minus 3 is minus 9, and this is plus 2 e raised to 3x. So total you will get this plus 9 and minus 9 get cancels, that is e raised to 3x divided by 2. This is particular integral. Therefore complete solution CS is equal to CF plus PI, and this is y is equal to, because which is in terms of y, CF is nothing but here C1 e raised to x plus C2 e raised to 2x plus particular integral is e raised to 3x divided by 2. This is the required solution.